Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustasan, your teacher for CSC 141 Introduction to Computer Programming. We are almost closing down our course, and we will be discussing few topics that will conclude this particular course. So today, before I take up my topic next, which is the IO stream, which I have already promised you in couple of times during my previous lectures that I'll be discussing IO streams. But before IO streams, I would like to spend few minutes to the data types that we have already studied in the beginning of the course. But today I'll be focusing on the internal representation of some very basic data types. You know that there are 5 data types in C language. What are those? They are integer, number 2 float, number 3 double, number 4 characters, and number 5 void, which means nothing. Then we have studied some different data structures and data types that we could define with the help of already defined these 5 data types. That included structures, unions, enumerated data type, arrays, etc. So before we conclude, it's very important that we should discuss the internal representation of some very simple and the most fundamental data type, which is the integers, float, and double. The integers are stored, rather any number that is stored in the computer is automatically first converted into the binary number system. And binary number system means a number system which has a base equal to 2. So basically we have just got 2 digits in binary number system, which is equal to 0 and 1. That's why we also call the computer as a bistable device. One state is 0 and another state is 1. Now, suppose we are required to store any decimal number. For example, if we are required to store decimal 107. So I would like to explain here that how does 107 will be represented inside the memory of the computer. For that purpose, we should understand that the zeros and 1 placed into the memory of the computer has a certain mathematical representation. So each bit is decoded and got its actual value with reference to its position within the byte or within the storage location. That could be a word, that could be integer, or that could be float. So for a bit that is stored on the least significant position, that is the starting position, we call this bit as a least significant. And if this is the byte, so this is the least significant bit, that is bit number 0, and then the bit number 7, which is in fact bit number 8, because we are starting from the 0. So it's a bit number 7 but position number 8. So this is the most significant bit, MSB. So we can put this number 0 1 1 0 1 0 1 1, and how it should be decoded. For that purpose, we can say that this least significant bit is 2 raised to power 0. 2 raised to power anything to the power 0 is 1. So it is 1, then 2 raised to power 1, 2, 2 raised to power 3, 2 raised to power 4, 5, 6, and 7. And 2 raised to power 7 is 128, 6 is 64, 5 is 32, 2 raised to power 2 is 4, and 2 and 1. Then we see that this bit is 1, so we pick up this 1 here. Then this bit is 1, so this position represents 2 raised to power 1, so it is 2, so we can say 1 plus 2. This we will not pick. Why? Because the multiplication of this position with 0 reads that there is no 4 present in this particular combination. Then 1 is 8, so we put up 8. 0 is not required, so it is 16. It's not required because it is 0, and 1 is 32, 1 is 64, so we added up, this number becomes to 107. So vice versa, when we convert 107 into a binary number, then the number is 1101011, and it could be calculated back with the help of 2 raised to power 0 or 2 raised to power 1 and so on, depending upon the position of that particular bit. So in this way the integer numbers are decoded and integer numbers are stored inside the computer, and the computer can easily pick it up from the storage. Then before I start the real numbers, some very important concept is that if we are dealing with the integer numbers, and suppose the 16-bit number is represented by the storage required by the integers. So the integer number may have 2 bytes, that means 16 bits, or they may have 4 bytes. So I have already taught you the way how can you find out that what is the size of the data type, integer, float, double, long float, long double, etc., to find out how many bytes the system will occupy and what is the capacity of your system. Accordingly, you can find out with the help of an operator which is called size of operator. Suppose your integer number takes 16 bit, then the bit number 16 has a significant meaning. That is, if we are dealing with a signed number, then most significant bit, that is the bit number 15, position number 16, but the bit number 15, if this number is equal to 1, then the number is calculated as a negative number, and if this number is 0, then this number is considered as a positive number. For unsigned numbers, for unsigned integers, we consume all the bits and we do not leave any bit that may be used as a negative or positive number. So that's why for the integer numbers, if we are dealing with a 16-bit number, so 2 raised to the power 16, 2 raised to power 15 minus 1 means that most significant bit that you have to leave it for the sign purpose. So you are left with the bit 2 raised to power 15 minus 1, which is equal to 32767. I've already demonstrated you during the demo session. But if you are dealing with an unsigned number, then this becomes 2 raised to power 16 minus 1, and the number is 65,535. And if we are dealing with the signed number of 32-bit integer, then this number is a long number, which is historically a very important number, and that's why I still remember that this number is 2147483647. So you don't need to remember, but whenever you deal this number very frequently, you will learn it. Okay, next numbers are the real numbers. The real number, a number that contains a decimal point, basically is a real number. Then a real number can be expressed, for example, minus 123.456, and we can have 2 types of notations, the scientific notations, and we can have some engineering notations. So then we can just use it, that is minus 1.23456 means that we have moved this decimal place to 2 spaces left, and then this number will be 1.23456. And since we have moved this number 2 spaces left, it means that we can multiply this number to the base 10 multiplied by 2. So if you multiply this number by 10 to the power 2, then this decimal plate will come back to its original position. So this is one way of representing the real numbers. So computer typically use some mechanism to represent this floating point numbers and double numbers, but it is bit more complicated as compared to representing the integers number into the C environment. So we would like to see that if we are dealing with the floating point numbers, then we are required to deal with 4 distinct components of the real number. What are these 4 distinct components? These 4 distinct components, number 1 is the sign, whether the number is negative or positive. It's mean that you are bound to reserve 1 bit that should take care of the negative number. Then the radix. What is the base? Radix, in the previous example we have seen that the radix was 10. So we need to determine that what is the radix, and in this particular case this was 10. Then the exponent. means the power to the radix, that is the which number system we are dealing with, and then what is the power. In this case the power was 2, 10 to the power 2, so the exponent is 2. Then the Manthisa part. The Manthisa part means that the 1.23456 is basically the actual number, and this is called Manthisa. So we have got sign, that is negative or positive, then we have got radix, then we have got exponent, and then we have got the Manthisa. So these are the 4 components of the real number system that we need to consider while representing it inside the computer. So when we represent the real numbers in a computer, we reserve one bit, that is a sign bit, that indicate whether the number is positive or negative. Then the base or the radix of the exponential, which is almost always in our number system it is 2, because the number is converted into the binary number system. But since we can also manage that, we need to convert the radix into binary, then we need to take care also the exponent also, that is automatically done by the system for you. Then the exponent to which the base is raised, sometimes this is an offset by a fixed number called bias. So we need to calculate the bias also, because we need to calculate it with reference to some fixed numbers. Then the Manthisa of the significant or the unsigned integer representing the number, that is the 4th component of our number system. So let us take this particular example, and we would like to see that how the float and double are taking place inside the computer. So if we are talking about a floating point number in C++, so typically the floating point number composed of 32 bits, means 4 bytes. Now what is the distribution of these 4 bytes? 4 bytes means 32 bit. This is a convention that 1 byte is 8 bit. So there is 1 bit reserved, which is a sign bit. If it is 1, it is negative. If it is 0, then the number is positive. Then the 8 bits are reserved for the exponent. So exponent ke liye when we reserve 8 bits, it means that 2 raised to the power 8 bits means 2 raised to the power 7 plus 1. So it is basically the combination that you can have, because once again this exponent could be a negative or this exponent could be a positive. So once again you have to sacrifice 1 bit here, and then there are the remaining bits are 7, and 2 raised to the power 7 is equal to 128. Since you start from 0, so the maximum exponent or bias that you can have is 127. Then 8 and 1, 9 bits. And then out of 32, if you take out this 9 bits, then the remaining 23 bits are reserved for the Manthisa. So this is for the floating point number system. For the double number system, that is a double is a data type that occupies or composed of 64 bits, means 8 bytes. So these 8 bytes, once again, 1 bit is reserved for 1 bit is reserved for the sign bit, and then out of 11, 1 you will leave it for plus or minus exponent. Exponent, as I said, could be plus, and exponent you can have a 10 raised to the power minus 32. So you have to be careful. Once again, this is a minus exponent, so you need to take 1 bit out of it. So then you are left with only 10 bits, and 2 raised to the power 10 is 1024. Since you are starting from 0, so your bias could be from 0 to 1024. And the remaining bits, which are 52 bits, are reserved for Manthisa. Since these 52 bits are sufficient enough, that's why we can have the accuracy, which is double the accuracy of the floating point number system, and we can easily say that that is 23 bit. Instead you are using now 52 bits, and then you can have a number system. Ultimately it's a decimal number system that can have an accuracy up to 15 decimal places. Okay, and one thing that you should understand that floating numbers and their accuracy, slightly, there's not very inaccurate, slightly inaccurate due to the fact of their internal storage. So with the help of their internal storage, you cannot have a very precise number here unless until you are using a double. Then you have to be very careful. Suppose A is equal to 1000.43 and B is equal to 1000.0, and when we say C out A minus B, you can say that it should be easily 0.43, but it is not 0.43. It is it is 0.0. It is sorry, this point should be here, so it should be 0.429993. So that's mean that if you round off this figure, then it should be equal to 0.43. Yeah, this is a mistake, 0 here. So just to correct it here, if I pick up this point, so this is 0.42, not this one. Okay, so I've just corrected it. Okay, characters I have already taught you in detail in the course, but here I will just try to give you an example that since we are not dealing with the 16-bit character set, which is a Unicode, rather we are dealing with the code which is an 8-bit code, and in our case the 8-bit code is either ASCII, which is American Standard Code for Information Interchange, or in the IBM mainframe machine that uses ABCDIC code, extended binary coded decimal interchange code. So in the ABCDIC code, when we are required to represent A, this is 81 hex. So hex में 8 is represented as 1000 is an 8 and 1 is 0001. So this is basically 81 hex, which is equal to small a character, or decimal में it becomes 129. And this in the ASCII, this A is basically 61 hex, which is 0110 is a 6 and 0001 is 1. So this is 61 hex or 97 decimal. Since I have already given sufficient explanation in the character, so I can just stop it up there. Then there is another topic which is called typecasting. Typecasting is basically for our convenience. Sometimes we are required to convert one data type into the other data type. That we can always do that during the execution of our program. How can we do that? It's very simple. We have a procedure which is called a typecasting, and we can typecast. For example, if we divide 5 by 4, and we can say that float 5 by 4 is simply 5 by 4, it is equal to 1.25 something. But if you want that you should have a number, for example, if you divide 20 by 7, then this is or 22 by 7, which is a pi, and you wanted to have a very accurate output. In that case, you can typecast it to a double. How can you typecast? You can typecast to a type, which could be a double, which could be a float, or even you can typecast from a float or double to integer typecasting. So you need to put this within the angle brackets within this parenthesis, and this is a type. For example, this is a parenthesis, and I have typecast here 4 by 5, and 4 by 5 is typecast to this double. So this double result will be saved into the data type, which is a double result. Okay, so this is basically called the typecasting. There is an example of the typecasting here. A is 5, B is 4, float is C and D. So you can have C is equal to A divided by B. And then you can show the output, and this could be equal to 0.000. Why it is 0.0? Because 5 divided by 8, this is an integer division because you are dividing it here. So this integer division by default will give you the no result, because it is by default becomes an integer division. So there is no exponent, so therefore the answer is 0.00. But if you typecast it and you say that D is equal to float A divided by float of B, so first it will convert B into float, and then it will convert first float as A float, B float, then this division is automatically will give you an output into the float, means you will get the accurate answer, which is 0.625000. So this is called basically the typecasting. So this was basically a topic that I could not explicitly discussed in any lecture, so I consider it appropriate to just explain it very briefly, and so that the topic should be covered. Now, dear students, I have already promised, I think 2-3 times, many times, that I will be discussing IO streams, because I have seen the number of students, I have met number of students who love to use C in, C out instead of using the printf and scanf facilities or functions available in the C language. So if you are interested to use C in, C out, then why not you use the complete power of the C in and C out as a IO stream? Since it is an IO stream, and we have a very powerful system, and since we are using the environment of the Visual C++ also, so it's mean that we have all the tools available, all the facilitations available. It is just a matter of understanding the capabilities of IO stream. So for that purpose, initially I thought that I should quickly touch and go through it, but later on when I've gone through it in detail, then I decided that I may be required to spend sufficient time. So maybe I'll be spending 1.5 lecture on this topic of IO stream, so that any teacher who will be taking up C++ or object-oriented programming should get the benefit out of it, that all the students who will be going for the advanced course should have some good understanding. And this will also lay down a platform of the object-oriented programming also, and I need to give you a brief introduction of the object-oriented programming. So I decided to go through it in detail, so that you can have a taste of the bit object-oriented programming also, for the member functions and some facilities that and the convenience available in the object-oriented programming. So bear with me, and I start this topic, IO stream. Students, you are familiar with the streams. At the time that I taught you the file processing, I defined the stream of bytes, or the stream of information in the form of sequence of bytes that we discussed at the time when we created the file. So this is the same stream. This is the same stream that we have already discussed in the file handling. That's why we will also be touching something that we have already discussed in the file processing. So this stream means that you can have an input stream and then you can have an output stream. That's why we can call it as IO stream. And then we can have some associated input and output operations with this IO stream. Input means a stream that flows from an input device to the memory. Input devices, for example, keyboard, disk drive, network connections, mouse. This is basically providing the stream of input, and that stream of input is called an input stream. And means that data flows from the input device and goes into the memory of the computer. Means that keyboard, say whatever data you enter, that is a stream of character you are producing, and you are reading this stream and putting it where? In the memory of the computer. And then from the memory of the computer, you are putting it back onto the screen of the computer. So that becomes an output stream, a stream that flows from the memory to the output device, and in our case the output device is the screen, although you can use another output device that is a printer also, or even the disk can also be used. In the file processing, we use the disk as an input stream to read the data from the disk and read it into the memory of the computer and then displayed it onto the screen. So your disk could also be considered as an input and output. That's why this disk drive is there as an input and this drive is there as an output also. So IO operations are basically considered as bottleneck. Why they are considered as bottleneck? Just because that IO operation takes or consume more time as compared to the processing of the data by the CPU. CPU is very fast. That's why what we have already studied in the beginning, that we try to make the operand, the input data within the CPU. How? We just tried to optimize that the data from the memory should quickly go into the CPU. Then we tried to provide the space within the CPU so that, which is called registers. So we tried to load the data within the register so that it could match with the speed of the processing of the machine. But since we usually perform the I/O operations through some devices which are electromechanical devices, like your keyboard, like your hard disk, like tape drive, like some other devices, that's why this I/O operation is always behind, it stays behind with reference to the processing of the machine. That's why the CPU is sometimes remains idle while an I/O operation is carried out or is being performed by the system. This I/O operation could be unformatted or formatted. If the I/O operation is unformatted, means that the stream you will not be able to recognize, but the system should be able to recognize it, and then the system has a importance of each and every byte because that contains the stream of input or the stream of output. This type of I/O operation is called a low-level I/O operation, which could be input or which could be output. But it is called low level, but it is a very high speed and high volume data can be read in from the device to the memory and from the memory and written back to the devices, provided it is unformatted, and only the system should take care regarding the formatting. But if you want to take care of the formatting by yourself, that you want to read through scanf and printf, and unformatted हम किस कब करते हैं? You still remember, yes, it should be from the read and write functions. It's unformatted, and it is a stream of the block that the system reads and writes in one go. But if we are dealing with not read and write, and we are dealing with the scanf and printf, it means that we are only interested in the formatted read and write. This is called a high level input output, and the user should be able to interpret it, and the bytes of data are combined into a logical units that you say that these are these integers, these are the characters, and this particular field contains the name, this particular field contains the salary, and that means that you are dealing in the high level I/O. And since it is easy to understand, but it is basically very slow because it requires a default conversion, and this default conversion takes it back again for the convenience of the system, which is a low level. So this conversion makes the system slow. So this is good for I/O, except that the high volume file processing basically will consume the larger time. That's why in the file processing session after a sequential file, we discussed the binary read, BR, BW, BA, that is a binary read and write, so that we could optimize the read and write operations also. So IOStream library is once again a facility, and I'm 100% sure that you must remember that IOStream.h. Usually we don't use .h. This is because when you are using the default directory, the current directory, then you need to provide the extension which is .h, which is the header file. But if you have defined the header file in the system, and you have defined the path, and you say to the system that pick up the data from the default directory, then you need not to specify .h there. That's why in almost every program and every hands-on demonstration, I've used IOStream and not used .h. This is basically the same file. The file is IOStream.h, but sometimes you are not required to put .h here. It is assumed by the system itself. So this particular header file contains the object. Now this is in as an object, out is an object. Similarly, there are two more objects which are called error and log. Error is basically, you can define error. It could be your monitor screen, but if you want to deal the system with the high level system or a mainframe system, then we have a device which is called a console. So we can define a console as a error. Console basically is a device that contains a keypad, but instead of the screen, the soft machine that contains the image, it contains the paper, so that whatever is printed onto the console, you should have a black and white evidence available to you. That's why this is called as a console. So sometimes we define C error console as a C error. Similarly, you can define C log, that could be a file, that could be a hard disk file on the hard disk. So you can define these objects. These are basically called objects. Then you can have an I/O manipulation. That I/O manipulation contains parameterized stream manipulators. Now, most of the facilities that we will be discussing in this particular lecture, I will be giving you both the option. One is considering the facility C in and C out as a member function, as an object also. You can use C in C out as a member function, or you have an option to use C in C out as a parameterized stream manipulator. Means they are treated as a function, and that means they should carry out certain parameters and provide you the service according to these parameterized stream manipulators. So we will be discussing both options in all the facilities that we will discuss very shortly. Stream input output classes and object. So input output stream, IOS, is basically input stream and output stream, I stream and O stream, that is inherited from IOS, input output stream. So this IO stream inherits from the input stream and output stream. Inherit means to extract, to inherit. Urdu में कहते हैं अखज़ करना, means to draw the definition, to draw the details that is inherited from something. जैसे कि we inherit from our parents, our the different characteristics in our what I can say, that certain characteristics that are available into my the shakhsiyat ke andar, into my personality, there are certain inheritance. That inheritance I have drawn from my parents. So there are certain inheritance that is drawn, and this inheritance of input stream and output stream is inherited from IO stream that is already defined. Then we have got these two operators, which is basically we have used it as a shift left or left shift operator that we have already discussed. But this time this shift left operator, if used with this IO stream, it will be overloaded as a stream insertion operator. Overloaded is a concept in the object-oriented programming where you assign certain operation to already defined operation to particular operator. For example, this is an operator which is a left shift operator, and it has got already previously defined operation. But if I would like to overwrite this previously defined previously defined operation, then this is called overloaded operations, and this is called operators overloading. So that is the concept of the object-oriented programming. आपके लिए it's a very simple, that is overloaded, that is stream insertion operator. So this is a stream insertion operator, means you will be inserted data from the into the stream. आपने एक stream के अंदर data को insert करना है. Similarly, you will extract. You need to extract. This could be used as a C out के साथ use करेंगे, because C out is taking a stream, is an output stream. So you will insert your input, and that is the stream insertion. But the from C in means a stream is available and you need to extract. So this is called a stream extraction operator. So both operators used with C in, C out, C error and C log, and with user defined system objects. So these are basically the system objects, C in, C out and C error and C log, and they use this stream insertion operator and stream extraction operator. Okay. So We have seen that IO stream, say we inherit input stream, then we inherit output stream, then we can combine these two as a IO stream, which is inherited as an input stream or as an output stream. So in terms of hierarchy, if we would like to see iOS called I stream and O stream, input stream and output stream, and then we can inherit from input and output as a hierarchy of classes. We can have define a class IO stream from this and O stream from this, so it is called IO stream. So I stream, which is an input stream, is basically an object, or as a class we can call it as a cin. So we can say cin grade, cin grade. So we need to perform certain operations here, which is the extraction operation. So cin knows what type of data is to be assigned to grade. So data is extracted and assigned to grade. So from the system first determines the data type of the grade. If it is an integer, then this integer stream is assigned to it. If it is a float, then the float stream is assigned to that particular data. This is basically a variable name. So we can extract the stream and assign it to that particular variable name. Similarly, the output stream, we can insert the output of the data type ggrade, and that is inserted into the output stream. So cout knows the type of the data to output. How does the cout know that? Because the grade you must have defined in your program the data type. Since you have already defined the data type, so the system knows that the grade could be a character, it could be an integer, it could be a float, or it could be a double. But you defined it before the start of the execution of the program. So initially you need to provide the prototype definition first, and that prototype definition educate the object cin as well as cout regarding the type of the data that the cin and cout possesses. Cerr, basically your error messages, so it must be it must have some data type, and it could be a string, that is the array of characters. So it's mean that unbuffered printout error messages means whenever a message appears, it is printed onto the console or onto the screen, whatever cerr device that you have defined. But sometimes you keep the all error messages, you keep the log of all error messages, and once the log file is full, then you display it onto the screen and you print it maybe onto the console. So this is the difference between cerr, which is an unbuffered, means does not keep the message into the buffer, but whenever the message is generated, it is printed. Whereas clog is a buffered print error messages, so as soon as the output buffer is full, then it is flushed, means the buffer is emptied and the data is printed onto the, usually printed onto the console. Okay, so we can just further define to this as, यहाँ तक we have already defined input, output stream, I stream, O stream, then we define IO stream. Then from the O stream we can extract, we can inherit another object. So this object should have the characteristic of output file stream. Similarly, we can inherit from the I stream input file stream. We can always treat keyboard as a file, and we can always treat stream as a file also. So why not, we can inherit the extract or inherit from the hierarchy of the IO stream, means from the classes we can always define new classes that inherit the characteristics of previously defined class. So IO stream has got certain class, from this you can inherit I stream, that could be a keyboard, that could be anything input device. Then you can, from this input inheritance, you can define I stream, I file stream. Similarly, you can have a output file stream, or then similarly you can have a file stream. That file stream means that it should contain input stream and it should contain the output stream. So O streams perform formatted and unformatted output. So we have already seen that in the file processing lecture, that when we use put, we use it for formatted output, and we use write for unformatted output. When we created a sequential file, we used put, fput. Fput means write down into the file. So that was a formatted output. But when we used fwrite, it was a writing to a file, a block by block, and we have already discussed that. Here you should just quickly recall that put means for the formatted and write means for unformatted output. So output of integer in decimal, octal and hexadecimal. That is another inheritance that we need to draw this analogy, that the system should also be able to print the output in the form of the number system, what type of number system we are dealing with. Okay, so then we also have in the floating point system, we can work in the precision. We can have a floating point number, could have a single precision, and then we can have a double, that we call it as a double precision. That is the accuracy up to after decimal places. If usually we say that if we have an accuracy up to 7 decimal places, we call it as a single precision. But if we can provide the accuracy up to 15 decimal places after decimal point, then we call it as a double precision number system. Then for the we can have a formatted text output, and we can control the format, and that we have already done it in the past in the filing system also. So stream insertion operator, already we have defined this left shift operator. We can define it as a overloaded to output built-in type. Okay, it can also be used to the output user defined type. For example, we can say that cout, and this is \n, that we use it with the printf function. So this is called the stream insertion, and later on we will see the stream extraction also. So this will print a new line, this will also print a new line. Since end line is a stream manipulator that issues a new line character and flushes the output buffer. Quickly after this one, it clears the output buffer so that you can just read that. Flush means flush the output buffer. Whatever the data that is already present into the buffer, you should clean that. So you can use it. Cout flush means delete whatever data that is there, that is you have read it from the keyboard, might be there. You may read it later on, but if you want that it should be clean, so you can just use it flush. This is a very good example where simple string that we use to print it out, that we have started with the C language, and it was a hello world string. So this has now been changed in C++. Welcome to C++. And here we are using stdout. So instead of writing here std, this operator, double colon operator, cout, if we define it here, then instead of using std this cout here, we can simply use cout there. And you also know another method that we have been using, and that was using namespace std. That is also something that I will demonstrate you next time when I will give you a brief demo. There is just, I expect there is one more demo is there scheduled for you. So very simple program, and here we have included IOStream, and here we are using this cout because we are using this with the help of object, and that object is cout object. This is the again output. Now we could break it down here. Welcome to C++. Then there is another way of doing that. Welcome to. It will just continue from this line because we haven't used \n. Still it will write welcome to, and then to write C++. So these both programs will give you the same output, welcome to C++. But you can see that you are using this object as a part of the output, then the part of the other output, then \n. So then this is the third option to give you the output, and this time it is welcome to C++, and instead of \n we are using end line. So this end line stream manipulator, this is also called stream manipulator end line. So we are using it as an object also, and then we can use it as a manipulator. Since we are to use it, so we can define it as using standard end line. Okay, using standard cout. And here what we can do also, 47 plus 53 is cout, and then we can put it an expression here, and from after the expression we can put up the manipulators, the parameterized manipulator. This is just the manipulator, not parameterized, but you can use it with the help of this object here. So we can just choose 47 plus 53 is, this is the string, and this is the output of the expression here. So cascading stream insertion operator is also allowed. What does it mean? It's mean that you can cascade, mean extend. Extension is also allowed. You can perform this extension that is called enable cascading cout how are you. So you can put it like this, cout this how, then you can have this cascading here, you can have a cascading here. Similarly, you can have a cascading here, but sometimes you are using the expressions, then you are bound to put the parenthesis. If you don't put the parenthesis, then it is 1, then plus 2 is something else. So it will give you an error message there, and you will not get the appropriate answer. Rather, it is plus 2 is something else. So it means the statement is not complete. So it means that you are required to put the parenthesis here, so that you can put just object 1 plus 2, expression is an object, and you can put it up here. So this is right, but this is not right, okay, because we have not used this parenthesis here. So the reference to the left operand object, that is a cout, is the left operand object, and we need to provide the right operand also. And then you can put different arguments, and these are for argument you can just play it by using cascading, or you can put it without cascading, that is assign the data, it will perform you the service. So this is the cascading for the cout. And this is the example once again, that we can just do it in a single line, and previously we have done it in 2 lines. Okay. Output of a character is a variable. So this operator will output a variable of a type characteristic. Characteristic किसे कहते हैं? Pointer to a character. Pointer to a character means it is a string. So pointer to a character, we can use an array also. Array as a pointer to character. Array is an array of character, so we can use the name of the array as a pointer. So we can also define it as a characteristic, means pointer to a character. That means you can represent a string also. So the output, the address of the first character of the string, cast the variable as the type void. If you want to pick up the address now, not the contents, and you are interested to print out the address. So what is the address? Address of the array is the address of the first element of the array. So if you are interested in picking up the address of the array, it will be the address of the first element of the array. That you can always find it out by using a void keyword here, which is a typecasting also. So I have just introduced you the typecasting here, and here I am using IOStream as this object, and then we have defined cout and endline object here. Here we have defined string, static string test. So I can simply say that cout this cascade and string, it will give you this test. Value of the string is test. But here I would like to use in the new line \n value of static cast, void. This is the way I should be using it. A string is, so this is just the string doing nothing, because everything has been enclosed in apostrophe and double quote, and \n is the only escape sequence that will cause to print out this string into the new line. That it will do. But here static cast angle bracket void static. So means you want to convert this pointer to a character string to cost to nothing. If it will cost to nothing, pointer cost to nothing means it will cost to its address. So that is another usage of that. So what it will print the address, and that is 0046C00T. This will be basically the address of this T. Basically this is address of this array, which is TEST, but you know the address of the array is the address of the first element of the array. So basically it is the address of the T here. Character output with member function put and cascading put. So now I will show you two different ways through which we can use put function. The first one is output one character to any stream, and obviously this is the output stream. So we are using it as a member function. When we use it as a member function, then we use it as cout object dot name of the function. Yes, जैसे we are using it as structure, name of the structure dot the member. Now this put is the member of this object cout, so we can say the member is cout dot this put is the member. So the class is out, the object is out dot its member put, and then you can say this A. Or if you want, you can just cascade it. You can use it cout dot put A dot put \n. This is just like cascading in parameterized that I have given you example before. I also give this example later on in the output. So cout dot put 65. You can write down a character as a single quote. Whatever is there is considered as a single character. So A means 65 decimal, or instead of that you can give this decimal. So the output of this cout dot output 65 will be equal to A, because this decimal A is the code of A. Or you can even have this one. If you use cout dot put dot A dot put dot \n, it will print A, and then it will print a new line character. So stream extraction and stream insertion, these are the true input and output extractions that we need to perform. So stream input is done by the stream extraction, that is you are reading a data and then you are extracting it out. What you are extracting the output. Out of the stream you are extracting the whatever input data the user has provided. So you are extracting that information. So used to perform the stream input, normally ignores white space. How many spaces whatever you provide, could be a single space, it could be a tab, or it could be a new line. So that features which are already there, so it ignores that, and returns 0 means false when end of file is encountered. So it does not terminate like scanf with the space, rather it terminates with the end of file. And I have already told you that in our case the end of file is the Control-C character. When you use a Control-C character, it's mean that it is the end of file indicator. So that indicator will only indicator that will terminate the input if you are reading it, extracting it from the stream extraction operations it performed. Means you are reading the data from C in, and you will keep on typing the data, and then you will press Control-Z. So control the state bits of the stream. State bits mean that fail bit or bad bit. I'll explain you later on. These are basically the flags, and maybe the later part of this lecture, on the next part of this lecture, I'll be coming back to this fail bit and the bad bit. These are the bits which are called flag bits, and we can see that whether our operation has been successful or unsuccessful. So this operator, which is basically the insertion operator or the extractor operator. This is basically insertion operator, this is the extractor operator, have a relatively high precedence. So that's why we need to put the data into the parenthesis over there. So the conditional and arithmetic expression must be contained in parenthesis, that we do that. So while here is you want to test whether it is true or false. So it has got higher precedence, C in grade. It will read the data and then is the read the data. If the data is non-zero, so it means that 5 is true. If this you will not type in any data, if the grade is false, it means that there you have not entered anything to the grade. So the extraction operator returns 0 for false, and when n of 5 is encountered, and then the loop is ended. Okay, so that we can always use it. Here is the example of that. So we can use here the object cout, cin, and then end of the line also. Cout enter two integers, and then we can have this extraction operator which will extract out of the stream x and y. So you will type the 2, here you will type 30 space 2. So it will distinguish that x and y through this particular space. So you will enter x and y, then you will press enter and see out sum of x and y is, these are the cascading. So sum of will be written, then the value of x cascaded here, it will be printed, then and will be printed, cascaded, then value of y is printed, and then you can have a sum. And this is also a cascading, another style that you can combine this and x plus y, and then you can have a new line character. So we can use, always use in the combination, and that is the defined here. So another example, same thing, we can do that. Here is the example of cin and cout. Cout enter the two integers, so you can type in two integers, then you can have a extraction of x and y through cin. This extraction operator will extract you x, this extraction operator will extract you y, and then you can have a check here, cout value of x, you can say that check whether x is equal, this is two equals operators, x is equal, question mark is, colon is not. So this is basically is called the conditional operator. The conditional operator is a ternary operator. It has got three operands. First of all, there is a test. If the test is true, then the answer is the second operand. If the test is false, then the answer is the third operand. Okay, so in this particular case, if x is true, it will print s, the extraction will be this is, or if the answer is not equal, then it will give you this output, which is not. So we can say that x enter 7 and 5, so 7 is not equal to 5, 7 is not, so it will say is not. So 7 is not equal, this is equal to, that will print equal to 5. And when you enter 8 and 8, so it will say 8 is equal to 8. So that's where you can just use the insertion and the extraction operators. Then there is another example of stream extraction operator that return false on the end of 5. So suppose you are to keep on reading the data, enter grade, enter the up to the end of the 5. So here it will keep on reading the data in grade, and started with it has initialized the highest grade to -1, so that whatever non-negative, obviously the grade should, the maximum grade lowest could be 0. So that's why it has been defined minus. So enter a grade, you will enter the data, it will read the data in cin as a grade, and then say that if grade is greater than highest grade, then the highest grade is equal to grade. Then you can show the output with the help of this enter grade. This is a text, and it will basically print out here. It is not print anything, rather it will print out after come out of the string, and then it will simply print out here highest grade is this grade. End of the 5, it will just print end of the 5. Okay, so when you print here, keep on entering the data. As soon as you print Control Z here, it will say the enter grade, enter the end of the 5 is Control Z. It will print that, and because that will already be there, and then it will print the highest grade value. So the output is this one. Keep on entering the data, 67, 87, 93, 95, 35, 99. Enter the end of the 5, and as soon as you enter Control Z, so that is there, it is the echo by the system, and then you have already placed the highest value, and that should be available as an output. So Next, we can quickly go through the member function get and getline function. There is we'll be using it as a member function, so you can use cin dot end of 5 that returns true if end of 5 has been occurred on cin. We have used dot end of 5 in file processing, but here we are using it as a member function of the object cin. Similarly, we can use cin get. Cin get will input a character from the stream when white space and returns it. Okay, so it will even read the white spaces, so it will keep on reading the data, and as soon as we press end of 5, then it will stop. So you can have a cin get or cin get c. Here it will inputs a character from the stream and return it. The function returns the data, and here it put the character from the stream and assign it onto this c. This is the difference. Here you can say that c is equal to cin dot get. Here you can say that cin dot get within parentheses c means whatever the data you have typed, character you have typed will be saved in c. So this is a very good example, and here you can just keep on typing the test before input dot cin dot end of 5 is. This is basically the display, and say that enter a sentence followed by the end of the line. So you will just keep on reading the data with the, and you say that if c is equal to cin dot get not equal to end of 5, so whatever the character you will read, it will type it onto the screen. So as soon as you have end of the 5, it will not type that, means it will print the whole data will be printed as a stream of character. So as a stream of character, it will be reading it and it will be putting it to the output stream. So this is the input stream reading the data, and this is the output stream. Okay, so end of 5 in the system is you will print that is, it will give you the output result, and then you can have a backslash and cin dot end of 5, and this cin dot end of 5 will be printed there. So basically, if you see this particular example, before input cin, end of 5 is 0. Why? Here we have nothing there as an input 5. So cin dot end of 5 is by default initialized to 0. But here you have read it end of 5, and it will be automatically saved in cin dot end of 5, and this cin dot end of 5 will be there, and you can just print it cin end of 5, and that means that enter a sequence of character. You will read it with the help of this. It will read testing the get input member function, and this is the echo function. This output dot cout dot output. This is input stream. This is input stream, keep on reading and automatically echo, and this is the output stream that we have defined in our function. Then we press Ctrl Z. As soon as you press Ctrl Z, it will read it, and end of 5 in this system is equal to -1. After input c in end of 5 is 1. So here c in, here end of 5 system is c. C was basically non-zero value, which says that it was -1, and after input C in end of 5, then you have used the data which is a non-zero data over there. So let's take another example before I jump up to the next part of this lecture, get and getline member function. Just like this function here, which was cin.get, here we can read cin.get array and the size. That's very important. You are using it as a pointer array, the name of the array or whatever the address of the array. It accepts 3 arguments: array, size of characters, that is the size limit that you are going to read, and a delimiter. At its default delimiter is \n, but you can define your delimiter also. So if you define a delimiter, then that delimiter will be treated as a delimiter, unless the array has uses the array as a buffer where it will read the data. And here the we will use a default delimiter here. When the delimiter is encountered, it remains in the input stream. Okay, means it is not extracted or not flushed out of the input stream. So the null characters is inserted in the array. Unless delimiter flush from the stream, it will stay there. Iska matlab hai that whatever delimiter you have typed in, that you have provided, that stays there into the system. Similarly, you can say that cin getline, it operates like cin dot get. जब array की जगह you have used buffer, size you still remain size, but it discards the delimiter from the stream and does not store it into the array. This is the only difference. cin.get means it also reads a file, reads one line, and you can define the default delimiter, or you can define your own delimiter, and it reads the delimiter and put it as a part of the stream also. But when we say cin.getline, it discards the delimiter. When it discards the delimiter, it means that you can not use it, means that you cannot use it implicitly, you can use it explicitly. So the null character inserted into the array, if your size, the data you have provided is less than that, so delimiter from the stream and does not store it into the array, null characters is inserted into the array. So this is the example of this this function, and that function is cin.get and cin.getline. So in this particular example, you can say please enter a sentence, then we have read it cin buffer 1. That is one way of reading it. Then it's by default when you use it \n, it will terminate. The string reads with the cin was \n. So then it will read it buffer 1 and \, mean two new line character will be printed. So it will read cin and then it will write onto the screen the cin, whatever you have read it in the buffer 1, it will output the data with the help of C output. This is extraction and this is insertion. यहाँ से आप extract कर रहे हैं, यहाँ से वापस insert कर रहे हैं. Then you can just read the data again. This is the by default is this one, and here you can use cin.get. Here you define buffer comma size, and once again you are reading it into the buffer 2. So enter a sentence contrasting string input which cin and cin.get. The string read with cin was here. Although you have typed the contrasting string input, so as soon as you press a white space here, it is terminated. And here 80 buffer, it will not read 80 character here, it will read as soon as you will type a space, it will break. So contrasting ke baad when you entered a space, it broke. But here you are not reading it as a array of character, rather using it as a function cin.get, and since you have defined here size which is 80, so it will read the 80 characters, up to maximum 80 character it will read. Okay, so if it is less than 80, it is terminated. If it is more than 80, still it will read it out. So cout string read with the cin.get function buffer 2. The string read with the cin was contrasting. The string read with cin.get was string input with cin and cout.get. This time we have provided the key input, but since we are using a cin and this we have provided the maximum size is 80, so it will stay in the loop and it will read the whole data. So that is still on, and this lecture I would still like to continue into the next lecture also, and would like to give you some more details and some more very interesting and very powerful features of IOStream, because it enables me also to give you a brief taste of the object-oriented programming, where we are using a member function, where we are inheritance the characteristics of the parent class of the parent object class. Okay, so I think we should stop here till the next lecture. So see you in the next lecture. Till then, Khuda Hafiz and Allah Nigehban.